You good?
Woo!
Okay, all right. What is up? Oh my God. Okay, my name's Arjun, that's Abhay, that's Yash, and we are Hacker Fab. Today we will be teaching you how to make chips in your apartment.
So this all started about 8 months ago when I met Yash at a Socratica event. I was like, dude, you're a pretty cool guy. We should be homies. And so, of course, because we go to Waterloo, the only way to become homies is to work on a side project together. So we started brainstorming ideas of things we could work on. And then Yash hit me with,
Bro, we should learn to make chips.
chips?
Yeah, chips, dude.
Oh, dude, like potato chips.
No, dummy. I mean computer chips.
Oh, okay.
Yeah, pretty cool.
Nice.
Yeah.
So like, how the fuck do those work?
Okay, basically, computer chips are just really, really tiny switches. And now, because they're so tiny, we have to use fingers, like we can't use fingers to press them. We use electricity to turn them on. And we call them transistors. Now, these transistors are everywhere. They're in your pocket right now. And they're so small. So this is someone zooming in to an iPhone chip until they can see the individual transistors themselves. So I was like, yo, Abhay, we should make these transistors.
I was like, okay, cool, let's do it. So I started looking into how these transistor things are made, and it turns out you can only make them in these super specialized factories called fabs. And there's really only one company in the world that does this, and they're called TSMC. They're like a little bit far away from us because they're located in Taiwan, but we heard that there's this building in Waterloo called the QNC, and supposedly they make chips there or something like that. So we're like, okay, this is worth a shot, let's go over there and see what they say. So that interaction went a little something like this. We went there and we're like, hey, we're in first year, we really like transistors, we just learned about them, can we like make one with you? And the PhD student there kind of just like stared at us for a little bit, and like a little bit longer. I was like, no. So that was very unfortunate. The whole reason we were denied access to this lab is because we're an undergrad, and resources like these are typically only reserved for PhD level students.
And we weren't really alone. We talked to a lot of our different friends, and they all faced the exact same problem. They wanted to make transistors and other cool projects, but they just didn't have access to the facilities to do it themselves. But then we heard about this guy, Henry, who drove 6 hours down to Carnegie Mellon University, and they have this thing called the Hacker Fab, and it's just the students, like a bunch of kids like us, making chips on their own from scratch. So Henry was like, yo, we should bring this to Waterloo. And Henry, again, somehow knows this insane number of people who have anything related to chip fabs, and he told us about Arjun, who's from Waterloo, and he basically taught us everything about chips. So we were like, Arjun, yo, how do we make chips at home?
Boy, am I glad you asked me that question. Let's learn how to make chips. There's only about 3 steps involved. So you pattern stuff, or outline them. Or you deposit stuff, which is adding stuff, and you etch stuff, which is removing stuff. And you do this over and over and over until you have chips. Don't believe me? Check this out. So you start off with some silicon. It's this little chunk there, and you use lasers and chemicals to pattern some stuff. You add some stuff there, pattern some more stuff, remove some stuff, and you won't believe this one? Add some more stuff back. You do this over and over and over, and you have a ton of these devices, and then you get a microchip. Well, of course, we didn't use lasers and chemicals to pattern. We used a projector. And you go, wait. Projectors make things huge. Nah, we just flipped the lens, because these chips are really, really tiny. And of course, by flipping the lens, we worked together and made this tool, and I'm very proud of it. It's a super cool projector. And of course, using this super cool projector, we made some really small geese. We're proud of them. You can see that right there. Fantastic. And it was, well, easy, right?
Well, so Arjun's a bit of a genius with this stuff, so it's easy for him, but it was not easy at all for us. It took a lot of grind, and I'll try to summarize it as quick as I can. So essentially, we didn't even have a place to work out of. So Henry, the goat, just decided to give us his apartment for 4 months, which is kind of crazy. And we turned this apartment into a clean room fab, kind of. It was very, very scrappy. So to do this, we needed a lot of equipment. So we would do things like go on Amazon and just buy things that we thought we needed. And then we needed more specialized equipment. So we would beg people on eBay to give it to us for really cheap because we had no money. And then things like a high voltage power supply would just show up at our door, which is kind of crazy. And then we needed chemicals to do some of these processes. And it turns out, if you go on Uber Eats, you can order chemicals. I don't know why this is a feature, but it exists. And being lab students, we were super safe, made sure to handle the chemicals really carefully. And then, of course, the only part where we didn't get scrappy was the biohazard waste disposal, and we made sure to do that in like a super safe way. But then eventually, like Arjun mentioned, we got these patterns onto our wafers.
Now, patterning is just one of the processes involved in making a chip. And then to make the other tools, we had to move out of the apartment fab, and we moved into a lab on campus. And now we started filling this lab with all sorts of machines we built for deposition, etching, patterning, annealing, all the different processes. Now, these machines were really cool, but they also had one really kind of funny feature. They would kind of kill you. Yeah. So there's a cylinder there. It can kill you. It'll blow up the room and kill you. There's a high voltage DC power supply. That will also kill you. The other thing, that will also kill you. This will definitely kill you. The last one will not kill you, but it will blind you permanently. So it's a little bit unfortunate. Yeah.
So Yash has been talking about these tools. We've been talking about all these different tools. Let's actually take a look at one of them. And now I know we're making jokes about these things being able to kill you. And yes, they are dangerous. But this tool that we're going to show, we've done a lot of testing. We've never had anything go wrong. So it's super safe. And so let's take a look at it right now.
All right. So what you guys are probably going to see here is some plasma, or if we're really lucky, some high voltage arcing from this tool. Let's see if we get anything out here. Ooh, it looks like we might have not been pumped down enough. Time constrictions. But what you see on stage is, well, what you guys saw on the slide. That was supposed to be it. Very purple, very nice, of course. And this thing quite literally vaporizes solid metal. And we take it, we collect it, we put it onto a wafer, make it conductive. That's how it goes. And of course, you might be thinking, wait. I'm in Waterloo, and you guys are doing some cool stuff. How do I do this? Oh, we made a design team. And we're a design team at the University of Waterloo. We call it HackerFab. And I mean, yeah, if you want to join us, go ahead, work on some cool stuff with us. And if you aren't from Waterloo, you can go to some other HackerFabs. There's many popping up around the world. There's stuff in the States, Poland, Japan. There's a whole bunch of places. And of course, there's people doing really cool stuff. Everyone has their own projects, and they're all unique.
And so if you're not in Waterloo, or if you're not near one of the existing HackerFabs already, that's okay, because we've actually open sourced all of this knowledge. So if you go on our GitHub, you can get a step-by-step guide on how to make every single one of these tools for a very low cost, and then make your own transistors. And the reason we want to open source this knowledge is because it's been gatekept for a very, very long time. So that's our GitHub, I think, over there. There you go. It's been gatekept for a very, very long time. We didn't have access to a lot of this information. Previous students didn't have a lot of access to this information. And transistors and chips are extremely important because they're the basis of all electronic devices. And so we think we should be pushing more and more people to get involved in this field. And so by ungatekeeping this knowledge and making it completely open source, we hope to do that. And so if you're into open source, hardware, chips, transistors, whatever the case is, we think you should go and start a HackerFab, and maybe you'll be up on the map next.
Join us. Please.
Let's go. Thank you.